Agentic patterns are recurring architectural designs and implementation strategies used in the development of agentic AI systems. These patterns provide a structured way to build autonomous agents that can perceive their environment, reason about goals, plan actions, and execute them to achieve those goals. They address common challenges in designing and orchestrating the behavior of intelligent agents powered by large language models, LLMs, and other AI components. React pattern structures the agent's thought process into alternating steps of reasoning and acting. The agent first reasons about the current situation, potential actions, and their consequences. Based on this reasoning, it then takes an action. Example, using a tool, querying information. The observation from the action is then fed back into the reasoning step for the next iteration. Observation. The agent perceives its current state or receives a user input. Reasoning. The LLM generates thoughts based on the observation, considering goals, available tools, and potential next steps. This often involves breaking down the problem, considering constraints, and planning. Action. Based on the reasoning, the LLM decides to take an action. This could involve using a tool, invoking an external function or API, example, a search engine, a calculator, a database query. Generating text, providing a response to the user or formulating a subtask. Observation of action. If an action was taken, especially using a tool, the agent receives the result or observation from that action. Repeat. The agent goes back to the reasoning step, incorporating the new observation to refine its plan and decide on the next action. This cycle continues until the goal is achieved or a termination condition is met. Plan and execute pattern separates the process into two distinct phases: planning and execution. First, the agent generates a high-level plan outlining the sequence of steps required to achieve the goal. Then, it executes this plan step by step. Goal definition. The agent receives a high-level goal or task. Planning. The LLM generates a detailed plan outlining the sequence of actions or subtasks needed to reach the goal. This plan might involve multiple steps and the use of various tools. Executes the plan step by step. This might involve invoking tools according to the plan, generating intermediate outputs, monitoring the progress of each step. Monitoring and adjustment. The agent might monitor the execution of the plan and potentially adjust it if unexpected issues arise or new information becomes available. This can involve a mini-planning phase within the execution. Goal achievement. Once all steps in the plan are completed, the goal is considered achieved. Reflection. Pattern involves the agent pausing to reflect on its past actions, reasoning, and outcomes. This self-assessment allows the agent to identify areas for improvement, learn from mistakes, and refine its strategies for future tasks. Task completion or failure. The agent finishes an attempt to achieve a goal. Data collection. The agent gathers information about its process, including the reasoning steps taken, the actions performed, the observations received, the final outcome. Reflection. The LLM analyzes this data, identifying what worked well, what went wrong, areas where the reasoning or action selection could be improved, potential alternative strategies. Learning and update. The insights from the reflection are used to update the agent's internal knowledge, strategies, or even its prompting mechanisms, leading to improved performance in subsequent tasks. Memory, or context management, pattern focuses on how the agent stores, retrieves, and utilizes information from past interactions and experiences. Effective memory management is crucial for maintaining context over long conversations and improving the agent's ability to handle complex multi-turn tasks. Interaction observation. The agent interacts with the user or its environment, generating new information. Storage. Relevant information, example, user queries, agent actions, tool outputs, learned insights, is stored in a memory component. This can take various forms, such as short-term memory, context. Window, the immediate history of the conversation or task. Long-term memory, vector databases, knowledge graphs. Persistent storage of broader knowledge and past experiences. Retrieval. When faced with a new situation, the agent retrieves relevant information from its memory based on the current context. This retrieval process might involve semantic search or other techniques. It's integrated into the agent's reasoning and action selection process, allowing it to leverage past knowledge and maintain coherence. Tool use, or function calling. This pattern enables the agent to interact with external tools and APIs to extend its capabilities beyond the inherent knowledge of the LLM. This allows agents to perform actions in the real world, access up-to-date information, and leverage specialized functionalities. Reasoning. The agent determines that it needs to use a tool to achieve its goal or gather necessary information. Tool selection. The agent identifies the appropriate tool based on its description and the current context. Parameterization. The agent generates the correct parameters or arguments required to invoke the chosen tool. Tool invocation. The agent executes the tool with the generated parameters. Observation. Tool output. The agent receives the output or result from the tool. Integration. The agent integrates the tool's output into its reasoning process to continue working towards the goal. Multi-agent collaboration. This pattern involves multiple autonomous agents working together to achieve a common goal. Each agent might have specialized roles, capabilities, and responsibilities. Goal decomposition. A complex goal is broken down into smaller subtasks. Agent assignment. Different agents are assigned to specific subtasks based on their expertise. Communication. Agents communicate with each other to share information, coordinate actions, and resolve conflicts. This communication can be structured or unstructured. Individual agent processes. Each agent follows its own internal process, which might involve other agentic patterns like react or plan and execute to complete its assigned subtask. Integration of results. The outputs from individual agents are combined to achieve the overall goal. Agentic patterns are not mutually exclusive and can be combined and adapted in various ways to build sophisticated and capable agentic AI systems. The choice of which patterns to use depends on the specific requirements of the application, the complexity of the tasks, and the desired level of autonomy and intelligence.